How do I store and exchange my genetic designs? Herbert Sauro faced this question back in 2006, and today he will tell us what he did about that. Hi and welcome everyone. I'm Erik Kubaczka, your host, and this is the very first episode of SBOLinside. Herbert Sauro is our first guest. He is a professor at the University of Washington in the US. He was the first chair of SBOL, and he was also one of the leading persons, if not the leading person, in the creation of the synthetic biology open language. Welcome, Herbert.
Hi, we're glad to be here.
Yeah, thank you very much for joining us. Really a pleasure to have you here.
Mm-hmm.
So, do you like to tell us what was the situation before SBOL, or what made all the folks think of creating something like that?
Sure. So you have to go all the way back to the 2000s. Around about 2000, two famous papers appeared. One was the repressilator, and the other was the bistable switch. That was a really important moment because it showed for the first time that we could actually build things from design in a cell, and they would actually work as you expected them to work. And those of us who are builders, who built Lego or whatever we build, saw this as an amazing opportunity to build something else. And so we started thinking. So I got interested in synthetic biology like that, and I met some of the main drivers of synthetic biology back then, like Drew Endy and Tom Knight. And I started thinking, they want to make this an engineering discipline. And so if you want to make it an engineering discipline, we're going to have some standards. And of course, they were already talking about standards like BioBricks. But we needed some computational exchange standard. And so this is where SBOL started. In fact, it was called something different at the beginning. It was called POBL, which is Welsh for people. Because it was a community effort. But Drew Endy then suggested SBOL, which is the synthetic biology open language. So that stuck. It's easier to say than POBL anyway. So I'd been involved in standard development before that. Of course, I was heavily involved in the SBML standard, and that was a successful effort. And I started thinking about why that was successful and how we could use the same technique to make SBOL successful. And the key thing I realized was to get people to meet and to get the young scientists to meet in particular. So Microsoft around about then came out with a grant opportunity in synthetic biology, and I applied, and we got the they issued 5 awards. We got one of them. I think we were the number one, and we used that award to kickstart SBOL. And we did it by I did it by setting up a workshop in Seattle. I invited about 40 people that I knew. A couple of PIs, not too many PIs, because as I said, what we really need are young people. They're the ones who have the excitement and want to push forward and make new careers and so on. And so we had 40 people gathered together for, I don't know how many days now it was. We just talked about synthetic biology and how we might standardize it. And that's how it started. After that, out of that 40, maybe 6 or 7 people were really interested and wanted to continue. That was my hope, and that's what happened. And for the next few years, we just gathered either in hotels or we didn't have online then, but in hotels, we managed to scrape through enough money somehow. I don't know how we did it. And we would meet, and we thrashed out the first draft of SBOL. That's how it started.
Oh, cool.
Yeah.
So when was the first draft, or can you give us a rough timeline from like the first Seattle meeting to the first draft?
Probably 2 years, maybe.
Oh, okay.
Yeah, it was all done out of hotels mainly.
Okay, so it's all right. Very interesting. But was that? I imagine that first draft wasn't like the version 1 of SBOL already.
It was pretty close to version 1 of SBOL, yeah. It's completely changed now, of course. It's much more sophisticated now. But the beginning, that's what it was. And we also used XML at the beginning because of my background with SPML. So,
Mhm.
and then we started writing software for it as well to read and write it.
All
That's how it
right.
started. Yeah.
Very cool to hear.
Mm.
So, like you said, from the initial 40 people, like 6, 7 are left over.
Yeah.
Have there been any other, like, let's say, hurdles in the creation of that standard? Like,
Well, I mean, money was always a problem at the beginning. I mean, none of the agencies in the US, at least, had any funding mechanisms for
mhm,
synthetic biology, even though there was a lot of excitement in the scientific community.
mhm,
The agencies just weren't interested for whatever reason. And so funding was a struggle. And ultimately, that's why I left synthetic biology.
all right.
There's just in the US, there was simply no support.
All right.
I mean, the only people who were interested, and this was some years later, was DARPA.
Mhm,
So the National Science Foundation was very resistant to funding synthetic biology. Now, after that, because I knew the SPML community quite well, and one individual in that community was Chris Myers,
mhm,
and I mean, I knew him really well. In fact, I consider him one of my friends, and he got into synthetic biology, and I felt that he was the ideal person to help out with SBOL, and he did, and he's since done a marvelous job of that. So, but I know he's found it difficult to get funding as well, but he's stuck with it, made it what it is today. So
yeah, cool. So, little spoiler, we will have Chris Myers also talk in one of the next episodes later.
yeah, he was
So,
a
but
very important individual in the development of SBOL.
yeah. So, like, until I looked at the chronology of SBOL in the recent SBOL 3.0 or 3.1 standard document, and there was a bit of time span, like, let's say, from the first draft until the first version, and especially until the official developers group formed.
Yeah.
Could you tell us what happened there, or like how did it evolve from forming a more rigid group?
Well, we started bringing in the mechanisms that we already used in SPML,
Mhm,
like setting up an editorial group. And that again is an important strategy because you give responsibility to the young scientists in the editorial group, and then you have maybe one or two senior people there as well. That's really important. I think it's really important you give the young people responsibility and an opportunity for them to build something themselves, and to own it themselves. That provides the long-term stability to any
mhm,
project like this. A lot of standards don't succeed, mainly because they don't pull in, people, champions, so to speak, who are willing to stick with the standard, even
mhm.
though time, it's difficult sometimes to get funding.
Yeah,
So
cool.
yeah.
So once you've got the chair of SBOL, would you
Hmm.
mind to give us a very quick overview of what what you have done then? So what did the company that let's say title or position?
Oh, what does it involve?
Yeah.
It's basically trying to find money. That's one thing, and encourage meetings and attend the meetings. Encourage those in the meetings to continue working, and to try to steer the project if need be.
Hmm.
Right? If the group seems to go off in the wrong direction, you try to bring them back a bit. So it's basically somebody who can keep the group going, and helping out where they can, and to
Cool.
maybe steer it in particular directions if need be.
Yeah. Have there so from today? I know there's also steering committee. Have there been other relevant persons like in that first years of the official ASBO
Um,
also moved it forward?
yeah, yeah. I mean, Brian Bartley was involved. I think he's still involved now, actually.
Mhm.
and Michael Galzicki. He was very important at the beginning. I can't recall the other names now. It's been like 20 years almost. I'd have to look them up, but I'd recognize their names if I did. But those two individuals, those two happen to be also, they ended up in my lab as well. But you know, they were really important too. And I know Brian has continued with it, and Michael now works for a biotech company startup.
Oh, yeah.
So he was good at organizing. He was a good organizer, and Brian was a good biologist, gene regulatory person. So I'm still in contact with them every now and then. So yeah.
Cool. Very good to hear. So maybe in that context of biology, or especially synthetic biology, where have you seen this the whole research area evolve and the position of SBOL within?
Well, I haven't kept too much with it, as I said. You know, after the first draft, even the second version came out, you know, funding was extremely difficult, and you have to try and maintain a lab, and I couldn't really maintain a lab on synthetic biology, because the agencies weren't supporting synthetic biology. The NSF wasn't, the Department of Energy wasn't, the NIH wasn't, DARPA was thinking about it. Now, with Chris Myers, we did manage to get a major grant from the NSF to support the standard, but it was very difficult to get. They're very reluctant to provide money for standards, and it was very difficult to get money to support wet lab synthetic biology. So I did have a wet lab, and we did some synthetic biology actually. But in the end, the funding was so bad that I pulled out. Which is unfortunate. I mean, I'm sure a lot of people pulled out, or who might have entered but didn't, and I think it was an enormous lost opportunity, at least to the United States where I am. It was only last few years that the NIH stepped in, but it's not really synthetic biology from what I see. It's more protein engineering focused.
All right.
So yeah, I haven't kept up with it, but I mean, after 2006, it was still very, very vibrant, and there was a lot of great stuff being done, and lots of circuits were being built, ideas were coming out. I mean, that was the whole thing about synthetic biology. It was a building project. It was really engineering, right? And at the beginning, people like Drew Endy, Tom Knight brought out that engineering, and that was one of the primary. That was one of the big things that differentiated it from systems biology, right? Systems biology is not engineering, synthetic biology is. And I think I feel that has somewhat diminished. And there's less engineering emphasis now and more just straight biology, protein engineering, which is unfortunate. I would like to be nice for the field to bring back more of an engineering emphasis. I know some of the projects that DARPA's funding are more engineering centric, which is nice. But still, the NSF is still not really funding synthetic biology. So,
do you think that the synthetic biology open language can help with that engineering aspect in the synthetic biology?
I mean, yes. I mean, the whole idea was that somebody builds something in a cell, right? And now you can use SBOL to formalize that design. And then, I mean, the vision was that once it's formalized in SBOL, you could pass it over to a company that would just make the thing for you from the SBOL specification, then send back either a plasmid or even an E. coli culture, and it'd be ready to go. Just like you do today. I mean, one of my hobbies is building electronic circuits. I can design my circuits on CAD at home, and I can just send the designs online to a company, and in a week I get back all the boards already made.
Yeah.
For me, that was the vision of SBOL. I could do the same thing. Could design something on a computer, and then send it off to a company. A week later, it would come back, and I would then test it out in the lab. That was the vision. I don't know how far that's vision gone. I mean, we relied on DNA synthesis pricing coming down, which I think it has. but yeah, that was the big vision. That's what differentiated it from systems biology. So
yeah, I think that was very cool to hear. So thank you very much, Herbert. I think we all have now a great impression on how SBOL started and how the first steps of SBOL made.
yeah.
And with that, we are already at the end of today's and this episode. In the next episode, Anil Wilpat, the second chair of SBOL, will join us. And yeah, will you be there?
I might be.
Yeah, thank you very much, Herbert. I really